All right, let's get started. Welcome to Office Hours. I want to spend some time thinking about a topic that you may have, that you may be blocked on. What's that?
So this is somehow.
Yeah.
Okay. Docker.
Docker. I don't know how relevant that's going to be though, but we can talk about it.
Microservices.
So you want to talk about Docker in the context of microservices? Okay.
Maybe how like Docker and like Kubernetes would work in like projects, like because I'm seeing a lot of open source things that use it, but I don't.
Okay. What else?
Solid.
Solid principles.
Dinner, curriculum, check boxes.
Mm-hmm.
And I don't know what this stands for.
Have you looked at? Okay, we can talk about it.
I don't know, maybe a simple deployment with growth. Like what? The app doesn't have to be huge. It's just want to. Whenever I do Heroku, I always feel like I'm stumbling over myself.
Okay. We did there was a talk this week on Heroku deployment, which I think you missed. So there's a video on it on YouTube.
Oh, okay. Never mind.
Design patterns for express routes.
Yeah, and I have the names. So I spoke with 14 people yesterday.
Where to start with open source?
Where to start?
Where to start? Yeah.
For like contributing to
Yeah.
open
If you
source.
want us to like where trying to navigate your way through where's the best place to start.
You good? All right. Cool. So Docker plus microservice. So Docker is basically this piece of software that helps create these lightweight VMs, which are like virtual machines, which are like light. I guess they're like this thing called containers. So they contain your software, but they also run in their own like sort of own operating system. Just like a thing. So most like operating systems, like wherever you deploy your app, are running on Linux machines, right? But a regular computer has a lot of like processes that it's running, right, to manage your operating system. It's running like network stuff. It's doing like memory management. It's doing like process management. It's doing like a bunch of things to ensure that you can run multiple applications on a box, right? But the past, if you look at the past 10 years of like deployment like history, you'll see that there is a lot of wastage of resources when you deploy software to like really powerful machines, like let's say like there's a 16-core machine and you're trying to deploy an app, right? Very few resources are being used because your app isn't constantly utilizing like 80% of your CPU. Like there's like spikes in operations. So a large portion of the time, like your system is just idle, right? So if you want to efficiently utilize your system, you have to get better at like deploying more things onto that machine. So you may want to like deploy more pieces of software on that machine. So you may have like your app deployed as well as your database, as well as like some other stuff, right? So to increase the usage of your resources. But the problem with that is that if one of those processes misbehaves, everything else suffers, right? Because it's running on the same machine. So let's say I have my database and my app running on the same machine. If my database suddenly like misbehaves and starts using 100% of my CPU, my app is going to suffer, right? Because it's the same machine. There's no isolation between the two apps. So that's where like virtual machines come in. Virtual machines are like running. So I'm giving you a little bit of history here. So virtual machines are like running like an OS, operating a fully blown operating system on an existing operating computer. So like a Mac, you can run like Linux on your Mac in sort of in a sort of a wall, like a boundary, and you can run multiple of these. So it's like having multiple computers, multiple virtual computers within your machine. So this gives you now each computer has its own isolation. Right? So like you can run your database on that virtual machine, you can run your app on another virtual machine, and they can talk to each other through like a network interface, because both of them are pretty much like virtual computers, right? So this is possible, and people have been doing this for the last many years. And running, there's this tool called Vagrant, which helps you like orchestrate like multiple like virtual machines on your local computer. So you can like simulate what would happen in the real world, where you deploy your computer to different different computers on different machines, and they have to talk to each other over the network. So Vagrant lets you like create like multiple virtual machines on your local computer and have that simulation of them having to talk over the network, over an internal network. So the problem with virtual machines is that they are resource heavy, because each virtual machine is its own operating system. Right, so if I need to run just Postgres on my virtual machine, I don't need like all kinds of other pieces of software like network. I mean, I guess you need network, but like there's a lot of like extra fluff that comes with an operating system, right? That's not used to Postgres. Postgres just means like network interface and maybe like a little bit of memory management. That's pretty much it, right? So there's Docker came up with this new piece of software, which is a lightweight virtual machine, which only has the essential features that it needs to ensure processes can run. It's sort of trimmed all of the fat, and it's only got this lightweight thing. And what this allows you is like, you can have a lot more containers on the same box. Before you could potentially have like 2 or 3 virtual machines on one machine. Like maybe have like 10 Docker containers on a single machine. So this is basically increasing the utilization of your computer's resources. So now what's happened is that Docker, so most of the open source projects have like a Docker file. It's basically telling you like what is the software. A Docker file is basically a series of steps that are run in this container, which installs the different pieces of software that that your app needs in order to be able to start itself. That's the Docker file. And all Docker, or rather most Docker containers are using this lightweight like Linux operating system underneath. So the idea of microservices fits in well with Docker because does everyone know what microservices are? Okay, so a microservice is just a small HTTP service that does like one small thing. For example, let's say we were like Uber or something, right? So Uber would have a microservice for just like user authentication. And all its functionality is that it authenticates users. Then it could have another microservice for like driver locations. All it does is like given a driver, it sends out the current location of the driver. And then you could have another location for the microservice for like the payments. And all it does is it like make sure like all of the payment information is stored and it like charges the right credit cards and all of that.
So are those just like endpoints that are like exposed or something?
Right. So usually there's this difference between monolith, which is like everything is in one app, versus a microservice architecture. So in a monolith, there's no reason where like all of these functionalities, which is like user authentication, driver location, and payments, can just live in one app. Right? You could just have like a folder called routes, and inside the routes you have 3 different files for each different kinds of like operation that you're doing. and it could just be one giant app, and you just deploy it, right?
So we're building monoliths.
Right now you're building monoliths, right? But it's fine. It's like it just depends on the nature of your app. If your app has a lot of things that it's doing, it's better to split it because then there's like pros and cons. So the pros are, or then let's talk about the cons. The cons are that now there's 3 different services. I have to deploy them separately. I have to have like 3 DevOps teams making sure they're all like working correctly. So there's a lot more overhead for deploying this kind of like microservice-based architecture, right? And you have to like also ensure that the services can have like good contracts to communicate amongst themselves, because the only way they can communicate amongst themselves is through HTTP, right? They do HTTP APIs, so they have to test them correctly. All of that has to happen.
Cores, right?
You can, if they're on the same domain, you can. So CORS is only a browser thing. This isn't a browser, right? You're making HTTP requests from server to server calls. So there's no CORS when it comes to server calls. So that's the cons. The pros are that now you can have like isolation. So like if I am on the payments team, I can update my piece of software and I can work independently and I can deploy my code separately. I don't have to depend on like this other person to like tell me that or give me permission to deploy. But usually that's what happens in a monolith architecture where like the whole deploy happens at once, and because things are so tangled up and a little complicated, there's like less frequent deploys, and there's like some sort of a gateway would be like, okay, now we shall deploy only if I agree can we deploy. Whereas in a microservices team, there's a lot more independence. So there's a lot more agility of your team, and there's a lot more like faster development.
So generally, if an app just continuously grows and grows and grows, eventually you will want to break it up into microservices.
Yes.
And then there's one company that search bars.
Right. So search is, for example, like a microservice, right? Because think of it as like how complicated is the thing that you're trying to solve for. Search is very hard to solve, right? Like you have a whole like team like indexing all of your data, making sure you're using the right algorithms behind the hood. So having a separate search team and then just controlling it and exposing that idea as an endpoint, HTTP endpoint, is great. Because then all you have to do is stick to the contract, which is the API. If I stick to the API, the internal implementations can just keep changing, and nobody has to even know. Kind of like what we were talking about yesterday with the configuration too, right? Which is like, under the hood, things can change, but so long as I stick to the API and the contract, things are always going to be easy for the client. So like Amazon, for example, has like microservices on the whole page. It's literally like, I think like 20 microservices which load under the hood. One is for the search, and there's like for the product recommendations, for the reviews, what else, like the deals. All those are separate microservices, and each of them have independent teams, and they only have to expose the API. And Amazon.com has to just like make calls in parallel to all these different services, and they just get information back. So where does Docker fit into all of this? So each of these microservices is just a Docker container, right? Can be deployed. So the advantage with using Docker, another advantage is, or using containers, not just limited to Docker, is that you can scale very easily. So you can basically say, I want to deploy two of these virtual machines, or like 5 of these virtual machines, or these lightweight containers, right? And they automatically spin up. So it's much easier to like auto scale. Have you heard of this term called auto scale?
Is that like Elastic?
So it's like when let's say like your app gets featured on TechCrunch, and you have a lot of like users who suddenly go to your website. There's a sudden surge and spike in your number of requests coming in, and that's going to cause your app to like potentially break at some point because it cannot handle that many requests. Right. So what you can do is you can set thresholds to say if my app is going above 60% for a minute continuously, spin up another container. So it'll automatically load balance.
Yeah, so it's load balance.
So automatic load balance can happen because of the fact that it's so easy to spin up a container. Containers are just like, here's an image. So does everyone know what an image is? So every Linux operating system has this idea of an image. It's like a .iso file. And what an image is basically, how do I best describe this? It's sort of a description, or actually not even a description. It's actually the whole like operating system like compressed in like a different format. And every operating system has different pieces of software that exists under the hood, right? Like, have you ever used like Linux or Ubuntu or something? Or even like, let's say Mac, when you say brew install X, brew install Y, that takes a long time to do, right? You're constantly doing brew install, it has to download stuff from the internet, it has to like, you know, inflate some packages, compile some packages, and install software. All of that is a painful process if you're setting up like machines from scratch, right? So an image is basically a snapshot of your current machine's installed software. It's already installed, pre-installed. So all you have to do is like take an image and like instantiate it and like copy it. It's basically copying it to your current file system. So it replicates like whatever the snapshot of your file system was. And that gives you like really fast way to spin up a machine. So like when you want to load balance and add another instance of your app, you just take an image and be like, here is a new machine, install this, replicate this other machine's like thing into this new machine.
Are they interconnected still? Like, for example, if you have like, I don't know, 7 images, right? Because your app grew, right? 7 images of the same app, and you want to redeploy, like you want to update a feature or do something, will all 7 be updated?
So what do you mean by you have 7 images? Is it each image? So every time you have changed the app, like you add a new feature, you're going to create a new image.
Correct, but also you create a new image when there's more users using your app, right? For load balancing, correct?
So you don't create a new image. The image is used as a template to create an instance.
Okay, so
think of image as a template.
And then you create an instance.
Yeah, and you create an instance.
So now you have 2 instances of your app.
Which have been created using the master image.
Correct. And then if you change the master image by redeploying, will that cascade down to both images?
No, you have to restart those 2 instances.
Oh, okay.
Or recreate those 2 instances based on this new image that you created.
Okay.
Yeah.
So I heard that like when these things get dispersed, they either go in shards, like, or another different way.
So sharding is like a database concept.
So I guess how do you know how it's separated? Is everything broken up into like? I think with sharding, it's like pieces of the app.
So sharding has nothing to do with the app. So sharding is like when in your database, if your database grows into like hundreds of millions of, let's say, rows, right? Sharding is like logically dividing your database into saying that when, let's say like you're like users, right? Like 100 million users, you're going to say like, and you want to replicate this data. So the way databases work is that, how do I explain this? So if you have 100 million rows, and let's say it's from A to Z, you're basically dividing the database up and saying, you're sharding and you're saying, I want to like split one piece of thing from A to Z. I mean, A to, let's say, not Z, A to like J, and then from K to like M or something, and then like N to like Z. Right? So there's 3 parts. So now whenever you request a user whose name starts with A, you go to this database. So you're splitting. So each database only contains part of your information. So that way you're logically load balancing.
That's just the data that has nothing to do.
Yeah, that's not an app. Sharding is a database concept.
Is there a way to like when the app?
So the app is agnostic to the kind of request coming in, right? Mostly. So when you can just like create new instances of your app, and that'll just like load balance automatically. Because the moment you create another instance of your app, you're sort of part of your load is going into that new instance. So the load on the other instances is automatically reduced. But with the database, it's much harder because
hard data in there.
So the way Postgres works is there's only one master. you can add like there's called this concept of masters and slaves. You can like add more slaves to your cluster, but the slaves are can never like add new data. It's only the master which is like the primary source of adding new information. So whenever something comes onto the primary data, it gets like sent across to these other like secondary sources, which are just like sort of slaves of the master.
Are they like replicas of the master?
They're replicas, exactly.
Okay, and then the other version is where it's like just broken up.
So the other version
like
is
MongoDB.
So don't talk about MongoDB yet.
Oh.
This is just like in the Postgres or like the SQL world,
Oh.
where you only have I could probably like maybe drawing it out.
From my understanding, like say you could have like 10,000 users, and then after you reach 10,000 users, you want to create a new shard of the database, right? So that way you don't have to search through all million users every time you make a database call, right? You only have to search through this small section.
It's actually not for reading. It's more for writing.
It's more for writing.
Yeah, because you can like easily replicate by you can like basically create new instances of your database, and that'll like split your read because every database would have the same data, right? So it's only the posts which cannot be done in other databases. All of the post requests can only go to the master because only the master can write.
Okay.
All of the replicated databases can only read. They cannot add new information. So there's a single point of failure for all of your writes, unless you shard. Because what you're sharding, you're basically saying A to J goes into this database. So all the writes for A to J will be handled by this database. All the writes from K to like P go to this, and all the writes from like what is that?
You're good. I'm like, you did a good job. You're like, just A to Z.
A to B, B to C.
So right, so like now each database is only responsible for like 1/3 of the writes, and then each database can have their own replication, like so each of them will have their own sort of like primary and secondary clusters.
Yeah, I found
But they're only responsible for like 1/3 of the writes. So that's how you're gaining like more balancing. Yeah, it's like failure.
Better degradation. I don't even know if that's the right term for graceful degradation.
I mean, it's like also like there is a limit to how much you can write. Right? After a point, your databases cannot like handle so many writes. You can like have thousands of requests, but after a point, there is some sort of a threshold beyond which you cannot write. Your databases just fall apart.
What do you mean by it cannot write? Because it's coming in too fast?
Yeah, it's coming in too fast.
Yeah.
Okay.
You have to divide the load.
We used to have that problem at the insurance company we worked for. And,
Yeah.
and it would just, the central database was just locked up.
Right. It just locks up.
So then that's when you guys would want to shard.
Yeah, but we could never convince them to switch off of their little platform. Yeah. So when that happens, that's when you would call technical services and tell them to start restarting the database processes, or to look at which item was in the queue that was trying to write and was trying to write too much and kill that item. And then everything would just start writing again.
Some software guy was talking about that, like shows you a map of your.
Well,
that doesn't come wrong.
that's another story.
Who shows you a map of your load balancers, like so if they're about to spike or something, you can do something internally.
There's like monitoring systems that you can exactly see what's happening in your cluster.
I was the monitoring system. It would lock up and I would call them.
Hey, bro.
Yes.
App.useKey.
Basically, they would email me. There was a term for the app. They used to call it clocking because it's like you're waiting, you're watching your clock, and then they would say, "Hey, the app is clocking," and I get emails like, "The app's clocking, and then I'd have to call New Jersey and be like, "What's going on?" "Oh, someone's trying to process the AT&T account." I'm like, "Why are they doing that?" "I don't know. We'll kill the AT&T process, and then everybody else could go back and take the business."
All right. So how's this holding up?
It's great. Done.
All right. So the next one is solid principles. So Jason, have you looked at the Wikipedia article on solid principles?
briefly.
I mean, I saw that it was a Wikipedia article.
Like, the S seems straightforward.
So this is something that we've been doing all the time, right? Open and closed.
Is that like closing, right? Like making sure scope is properly.
So it says the module is set to be open if it's still available for extension. For example, it should be possible to add fields to the data structures it contains or new elements to the set of functions it performs. The module is set to be closed if it's available for use by other modules. This assumes that the module has been given a well-defined, stable description. Let's look at some examples actually. Let's look at that.
So it seems like something that will be more relevant for teams, maybe.
I mean, it's more relevant. It's kind of like when you're designing your architecting your system, you're looking at your code to see if these things are applicable to the code that you've written. Kind of like a measure.
So if you were to like export a class, right? What would that be? Would that be an open or a closed?
This isn't about like whether your class is exposed. It's more about like how have you designed your. So anyway, we'll take a look at an example. Yeah. So open for extension means that we should be able to add new features or components to the application without breaking existing code. That's what it means. So if I add a new function to your class, does that break somebody using your class?
I see.
Close for modification means that we should not introduce breaking changes to existing functionality, because that would force you to refactor a lot of existing code. So that's what you want to. So that's like kind of what we were talking about yesterday too, with like the config stuff, where you can change the internal implementation, but that shouldn't like affect your clients. So let's see, what's the example? So the area calculator factory function. So we have a function called sum, and it does some stuff and it returns it's such a weird function because it's like pushing the area to an array, but I could imagine there's only one. This condition could only be executed like once. Like it's either a square or a circle, right? So why can't they just like directly return the area? Okay, whatever. If you want the sum method to be able to sum the area of more shapes, we would have to add more if-else blocks, right? That goes against the open-close principle. A way we can make this sum method better is to remove the logic to calculate the area of each shape out of the sum method and attach it to the shapes factory function. Right, so you're making the area a property of the square. Instead of having like a class called compute, sum or compute area, instead of dispatching on like the type, you can have each shape can have an area function by itself. To calculate its own area. So then it's the responsibility of the new shape. If you have new shapes now, it's the responsibility of them to make sure how to compute area, and then the caller can just like delegate to that function. And that's what's kind of happening here. Where so like square now has its own area function, and then circle too. I was circle. Yeah, okay. They don't have an example, but circle. But like a circle, if you would have const circle, and then it would have its own like area function, which would be like pi r square, right? And then when your sum function, you're just calling shape.area. Like you don't have to check to see what is the type of shape, what is the thing. Like that is because now the shape has its own way of computing area. You just delegate. You're like, hey, shape, give me your area. You know how to compute your thing, give it to me. So that's what it says. Coding to an interface is an integral part of solid principles. Right? So like, so what they're saying is like, when you're calling shape.area, that's making a huge assumption that every shape has a property called area. But that's what contracts are. It's like you follow this contract to say that every shape is going to expose this property called area. That's something you have to set before you start writing any code. This is the design phase of your app. You're like, okay, I'm going to create this contract. Each shape is going to expose these properties, and then I can be sure that my application would work because everybody's adhering to that contract.
Would that mean that, like, if we want a square, we'd say, okay, square equals const square equals new shape, and then it lists all that type of stuff?
Yeah, but like it would also have its own set of properties, right?
Yeah, in addition, or like, what if you had like a shape, like just a shape constructor function that says, oh, this is needed, this is required for all of the things, and then when you say, oh, a square, I want to instantiate a new shape, and then identify all of those. But is that typically how it's done? Or?
Yeah, so you will override. Sure, you will have like some sort of an interface. It's basically an empty. Like an object with like just the properties, and the values are just going to be empty. Like it's not going to have like a generic shape has no area, for example.
Yeah.
Right? It'll just be like, oh, I expect an area, and I expect like a type, or I expect like number of sides or something, right? Like all these different properties. Like that's your interface definition. And then each new shape, like a circle, will now use that interface to implement the methods that are defined in the interface. So you would be like, oh, I have to now implement the area function. Like, oh, I have to implement the size function or whatever, right?
This was an instance of the shape class.
It has to ensure that all of the methods which are defined in the contract or the interface or whatever you want to call it are implemented.
Okay.
So then you can also have a checker.
Yeah.
You can be like, oh, does my existing shape adhere to the contract?
And then it says like, oh, you haven't defined area yet, so
right.
Please.
Right. Throw an error when area is not defined.
Yeah.
Smart contracts. I'm sorry, I'm not going to talk about crypto, but smart contracts is how it works too. Like with certain standard, like cryptocurrencies, they have like a certain contract that says actually this function needs to be implemented behind the interface, basically. Actually have these cryptocurrencies.
Right.
That's how you basically talk to them.
Yeah. Like we work in a world of contracts, right? We all drive on the left side of the road here. Right now, we drive on the right side. Sorry, my bad. In India, we drive on the left side. But like those are all
why
contracts.
it's confusing.
Yeah. Which is when there's no standards, that's prone to error, right? Like you can. I've done that once. I drove on the left side one day. I was like, shit.
So
So that's what the O stands for. Cool. So where's the L? So Liskov substitution principle. Wow, so this is very mathy. So let Q of X be a property provable about objects of X of type T. Then Q of Y should be a provable property for objects Y of type S, where S is a subtype of T. I see. So it's for subtypes. This will get a little bit more clear with an example. So let's look at an example. All this is stating is that every subclass derived class should be substitutable for their parent base class. So that means like if you have a shape, right, which is a generic parent class and has these properties, and then you have a subclass called square, which is deriving all of the properties of the parent class, you should be able to use the shape class everywhere where you could have used you should be able to use the circle class or a square class anywhere where you could have used the shape class, because the circle and square have been derived from the parent shape. right? There would not be any extra properties of the parent that wouldn't be in the shape's children, which are circle and square. Does that make sense?
Yeah.
Wait, the child could have more.
The child could have more.
Yeah.
So if you look at sets, you're like the child is going to be the outer set and the parent is going to be the inner set.
Okay.
Is that like different when you're doing prototype? I can't even say the word inheritance, where it's like putting it on the constructor and putting it on the prototype.
Right. So whenever you do extends,
Uh-huh.
what you're saying is that all of the properties of the parent get added to the current class that you're extending.
So that's
Yeah. So that is this. Yeah.
And I mean, is there any instance where you would extend something and that wouldn't be true?
No.
Okay, so it just happened by default.
Yeah.
But I think it's something to keep in mind.
Yeah. Just something to think about that you can replace it.
Oh, okay.
Like you would have.
Yeah, like would work.
Unless you're doing your own, because you're using like classes under the hood, like it does it correctly. When you do like, you get all of the properties of your parent and you merge it with your current object. But if you were doing it yourself, you could not do it that way and make a mistake.
Oh, okay.
And you
Without the extent.
Mm-hmm.
Okay. Well, just a quick question before you leave that. Like with the prototype, I mean, to go ahead, with inherited situations, sorry. Yeah, if you put it in the constructor versus prototype, I'm confused as to which one is private or which ones are hidden, which ones are shared amongst all the children.
There's no such thing as private. All properties are public.
Or one of them makes a copy of the same function over and over again, and the other one just gives you access to
So
it.
the prototype is like the
Shared amongst all the children, and the other one is like you have to just declare that. Right?
Yeah.
Okay.
one is a actual property of the object, and the other is a reference.
Okay.
Did everyone get that?
So anything in the constructor function is the reference to whatever you pass it to parameters, right? Or is that what we're talking about?
No, we're talking about prototypes. So prototypes is a separate object, right? That has a bunch of properties which are defined, which are accessible by your object if the prototype of that object is set to this other prototype. Those properties are not defined on the object itself. They're defined on a separate object, which is the prototype. Does that make sense?
Prototype is like a step up.
Yeah, a prototype is a step up in a way, or a step away. Could be like, and that prototype could have another prototype. That prototype could have another prototype. You can keep going until you get like
Then prototype.
you get none. You get none. At some point, you get like none.
Okay.
That's the end.
Sorry.
Yeah, that's a good question. All right. So next question. Next principle. Interface. This is the fourth one, right? So interface segregation. A client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods they do not use. So, to continue with our shapes example, we know that we also have solid shapes. So since we would also want to calculate the volume of the shape, we can add another contract to the shape interface. So this was the interface that I was telling you about. Right, so you have an interface, which basically is an object, and it has a bunch of properties. So now you have basically saying now you have a third property called volume, right, that they want to add to the interface. So any shape we create must implement volume method, but we know that squares are flat shapes and they do not have volumes. So this interface would force the square factory function to implement a method that it has no use for. So interface segregation says no to this. So you shouldn't be doing it this way, is what they're saying. Instead, you should create multiple interfaces and then merge them if you want to create a solid interface. Right? So like here, we have a shape interface which has a type and an area. And then we have a solid shape interface which has a type and volume. So we have a cubo. Right, so proto basics complex. Okay, so I don't know why this person is unnecessarily made it a little bit complicated. But all they're trying to say is that you're separating out it into two separate interfaces. So then you can share properties. Right? So if you have a solid shape, you can be like, oh, a solid shape has properties of a flat shape as well as there's other properties of a solid shapes. Whereas flat shapes just have properties of the flat shapes. So you're getting more composability. You know what composability is? Yeah, putting things together. But in order to put things together, things have to be small.
Different Lego pieces.
Yeah, it's kind of like different Lego pieces. But like, yeah, small enough that you can compose them to build bigger Lego blocks.
Snap two buildings together.
And like functional programming stuff.
Mm-hmm. Yeah, this is function composition.
So we do everything.
Well, this is object-oriented, though, right?
Yeah, functionalism. Object-oriented, functional.
All right, dependency inversion principle. This is actually a very important principle. Dependency inversion. And this basically means anyway, you can like look at it. So entities must depend on abstractions and not concretions. It states that the high-level module must not depend on the lower-level module, but they should depend on abstractions. So as a dynamic language, JavaScript doesn't require the use of abstractions to facilitate decoupling. Therefore, the stipulation that abstraction shouldn't depend upon details isn't particularly relevant. The stipulation that high-level modules shouldn't depend on low-level modules is, however, relevant. Yeah, so basically...
I have a quick definition.
Yeah.
Decoupling? Let's do decoupling.
Decoupling is like, there's no dependency between two things.
Oh, okay. So
they're not coupled together. Sure, you can say that. They're pure, yeah.
Okay.
They have no... They don't... there's no state that... there's no reliance of this module with this module.
Okay.
So if this changes, then this doesn't affect this one. That's what it means.
It's like when you pick up on like front end and back end, almost.
Sure, that's, yeah, things are just like talking to each other.
Yes.
Like, so there's a contract between the two.
Sure.
Like
Or-
the API you're talking about. As long as you maintain that same contract, nothing that you do over here is going to affect over here.
Right.
Yeah.
Or you just pass things as arguments,
Yes.
right? That's instead of like having this reference, like the function referring to something outside,
Absolutely. Exactly.
you just pass it as an argument
Exactly.
to avoid dependency.
Yes.
And
So you can like easily like swap out the back end from the front end, right?
Exactly, yeah. And you can like you can swap things out.
Not relying on it.
So for example, like a good example is like if you're using, if you have a contract for the way you are, let's say, getting like users, right? Let's say you have a user interface. You like find me the user using the ID or something, right? Find user or find my ID, let's say. And then you pass in an ID, right? So let's say under the hood, this is using Postgres, right? If I want to change Postgres to something else, so this is what the client will use. So somewhere here, user is equal to something, right? So you would basically say maybe like user is equal to require like db / Postgres. Okay, sorry, db / user. Right, you're doing this somewhere. So if you want to like change the implementation of Postgres, let's say to Redis, which is like another data store, the client shouldn't care.
Exactly.
Yeah. Right? It should be transparent to the client. Like this should remain the same.
Okay.
Like even this should technically remain the same. Yeah. So that's what it is. It's kind of like you're not coupling the client to the implementation of how you are what is the technology you're using under the hood?
Or as minimally as possible.
So like here, how you would do that, how you would achieve that is by
You would just change your connection
so
straight.
require would take in some extra arguments. This would just be DB/user. Or actually, maybe in DB user, you will be like changing the way you are basically initializing your user object. So instead of taking like a Postgres connection, you will be taking a Redis connection, and it transparently works under the hood. And your client can just continue to call the same function, and it would be just talking to Redis instead. Like it wouldn't know that suddenly the connection has changed to Postgres, or changed from Postgres. So, how is dependency inversion related to higher order question? All right, so let's read a little bit about this. So, how is dependency inversion related to higher order question? This might sound loaded, but it's really easy to understand. The principle allows for decoupling. As we have made it before, let's review our code with manage shape interface and how we accomplish the calculate method. So manage shape interface is like a generic method which has a function called calculate. Based on the shape, it's going to call this function, which is being passed as an argument. So you're passing a function as an argument. So it's a higher order function. That's why they say higher order function. What the manage shape interface factory function receives as an argument is a higher order function that decouples for every shape the functionality to accomplish the needed logic to get to final calculation. So, right. So here for our square, we're calling manage shape interface, and we're passing a function which calls, I don't know what basics is here, but I guess basics are somewhere defined here. A shape interface of proto. The shape interface is shape interface. Yeah, basically had type and area. Right, so it was adding. So it was passing in like these properties for the circle, and then calling the shape interface function, right, which takes in some state, and it calls area, the area function. So, okay, so it replaces this function as the area on it. So going back here, when you say basics.area, it's going to basically call that function, which gets replaced.
Hit the function that gets called.
Right. It's kind of similar. That was an example for circle, but for square, the function would be like the square of the two sides. Right? I mean, not two sides. The square. I mean, square of the sides. Like it would be like instead of pi r square, it would just be r area, side into side. So what you're doing is you're so you know within the context of a square function, you know how to compute the area. So you're just sort of delegating. You're saying that I'm creating these using these different interfaces and passing the right object, and using that object will contain all of the implementation details of itself, and that gets like sort of replaced by whatever is in here, right? Because state.area is whatever you pass in. Is everyone understanding this? I was kind of going over the heads.
Oh yeah. Maybe a code. I mean, like a library.
These are just examples.
Yeah.
This is like meta concepts.
Yeah, it makes sense. It's just the implementation. It's just hard to keep it.
I would say solid is on the same level as like
try, right? Like, okay, things to keep in mind while you're coding, not necessarily like this exact example, right? Yeah. So, okay, so going back here, we were getting, right, so we have abstract C on. So you're adding the area plus the volume. I don't know why they're doing that, but so let's read. So what the manage shape interface factory function receives is an argument, is a higher order function that decouples for every shape the functionality to accomplish the needed logic to get to the final calculation. Right. So for the square, what we need to do, what we need to calculate is just getting the area of the shape. For a cubo, what we need is summing the area with the volume, and that is everything needed to avoid the coupling and get the abstraction. It's a weird example.
You're adding the volume.
So they basically replace. So this is a function, right? So manage shape interface takes a function, and I guess the cubo is a figure which is like the area. I don't know. They're adding the area with the volume. I don't even know what a cubo is. But anyway, so just assuming this is like a new shape. What's that?
This math is just really. This example makes the concept harder.
Yeah.
You know? But
okay, let's
yeah,
see if I can find a different blog.
I understand the concept though, right? You guys.
Did you understand the concept? Is everyone?
Yeah, decouple it. Pretty much ensure that everything has its own level of functionality. You don't put unnecessary functionality. Right?
Wow, this person did the exact same example.
He was like, I don't understand this, so I'm just gonna copy.
And they use Java, I guess, instead.
Well, maybe let's not do it.
Yeah, it's tough.
What about the Bob? He's in there. He's a computer or something. So.
Clean code, right? Yeah.
Yeah, clean code is great.
They didn't know where that, but
Oh,
You
these
did
are
it?
videos.
no.
Really? I read like a third or half of it.
Yeah, I was doing 3 at the same time.
Clean code is a really good.
Oh, this one, I see.
Yeah. But I stopped reading on the board. I got too much.
Yes.
Like I mean, too much code.
Yeah, I think it's time to get back.
But he makes more than
Maybe.
I'm doing that now. I think I need to
Maybe that's right. Maybe it'll be a lot easier now.
Yeah.
I don't have to read like I don't know 10 pages an hour or something.
So this is a bad example. So we have a class worker, we have a manager. So this is like Java, so slightly different syntax, but it's kind of the same. Like ignore the public, it just means that they're exposed functions. So a manager takes in a work, I guess, has a set worker function and a manage function, and all it does, it delegates to the worker. And the super worker does some other stuff. So in this new design, a new abstraction layer is added to the iWorker interface. So this is kind of like the interface that we were talking about, right? Like, so the prototype is an interface. You design to the prototype, right? So you're creating an interface, which means that every person which implements this interface will need to define a work function. So everybody knows how to work. So now you have a worker, it implements the iWorker function, so then it has to define its own work function. Like this would throw Java would for example throw an exception if you don't define that function because it doesn't adhere to the interface, right? So then if you have a super worker which implements iWorker, it should have its own function too, right? And then a manager, and the manager just has to care about, like it doesn't care about which exact worker it is. It just knows that it is something that sticks to the interface, and then it can just call the work function. And then anybody who sticks to that interface can then be managed, right? A manager just has to know that, oh, are you an iWorker kind of a person? And if you are, then I can just call a .work function on the .work function. So if you always stick to an interface, you can be sure that that person has this function defined. Like that's all it is in the end. Stick to interfaces and stick to contracts. That's pretty much it. Those are the solid principles.
Excellent.
All right. How are we doing on time? We have 2 minutes. Okay. Design patterns for express routes. What was the question?
Well, the question is, I've seen routes written in so many different ways now that it's like, is there a more like efficient way over the other? Like, making an object, and inside that object you're storing all your routes, and then you export that object, and then you have your server like call that, or is it better to do something where it's like you have like individual routes, and then your module export has like lots of things, and then that goes somewhere else, things like that.
Yeah.
Can I respond to that?
Sure.
And then say what I do, and then if I get it wrong, then you correct me as well. So typically what I do is like you have several different routers, like several different routes. Like you have for your /users, you have your /users router, and then you have like your I don't know, items, right? Where you want to get items or post items, right? Right? So what I do is I make a new file for each one, right? And then I import all of the routers into an index.js inside of my routes folder. So I have a routes folder with like a users file, items file, all of my other routes, and an index.
Yeah, but then the question is that pattern better than some other pattern? I understand like
you
to
understand
design
that
it that way. Yeah, I understand that pattern, but then I see someone else build it this way, someone else build it that way, and it's like, what's the most efficient way?
Okay.
I think it's not about efficiency, it's more of like organization, and
So it's just organization.
Yeah.
So whether you do it one way or the other wouldn't affect like if you had a app that then scaled up and now you have lots of users, like it won't break.
No.
Based on which pattern you're using?
No, it is because in the end it will just add the routes to the same server, right? So under the hood is just adding routes, but it's just a way of like organizing your code such that it's easy to know which file to modify when you're trying to change a particular route, or even trying to find a particular implementation of a route that you're trying to like, as a programmer, trying to see.
So it's really all just about organization then, and there's no like performance gain or something that would hurt performance between.
Also, like I think like what John's method is, I think is probably for me personally the nicest way to write it.
Right.
Just because like you get benefits of like in your server file is where you just have to like write one line to get all of the routes in.
Yeah.
Right? You just import your index file.
Yeah.
And then you get like all of the routes. You just have to modify like the server file in a single line. And all of the routes related code lives in the routes.
Yeah, it lives in the router.
In the routes folder.
Yeah, and then on the server you would just have like one app.get, it would get slash, and then it would say like routes, and then that.
So in my opinion, like the server file should have like single lines for like the different components of your system. So like let's say you're doing some sort of authentication, you're doing like maybe like some Facebook Connect stuff, you're doing like database initialization. There should be like an init function which is called just initialize auth, initialize database, initialize Facebook, or initialize routes. And that's it. These 4 lines, and each of those functions may be doing a lot more, but that's their responsibility. The responsibility of the server is just to call out to that function. Yeah.
All right, I have another question. So and it does relate to organization and design patterns. So say, I've never encountered this, but we have like a bunch of very small applications, right? What if you are on a page and you have, say, 2 forms on that page? How do you identify the different post routes for that? Because generally, like I would put, say, like whatever the URL is, .get, and then the URL of .post. However, if we have like multiple posts, what's the best way to organize that from a single page?
So you have a single page which has 2 forms.
Yes. I'm just curious if that is normal or.
I mean, you just have different like URLs for each of the routes, right?
Yes.
So you would organize it that way. The URLs would be different.
And we just would name it whatever, like.
Whatever the form is submitting. So if it's, I mean, I'm finding it very hard to. I mean, maybe you can have 2. Like you may have like a form for a post, and you may have a form for a comment.
Yeah, exactly.
Right? So the post would be in a separate file, right? All of your post routes would be in a route/posts.js, whereas all of your routes, your comments would be in like route/comment.js.
Oh, okay.
Unless you're like 2 forms to the same resource. So always think of what is the resource that you're trying to manipulate or change. That's kind of like the restful way of organizing your code, right? So like in this case, you're modifying the posts resource. So all of my routes associated posts would live in a single file, and then the names of those routes would be based on what am I trying to do. If I'm trying to create a new route, it would be /posts.
Yeah,
right?
I guess in my mind, I'm just thinking like, for example, when you're commenting on Facebook, right, you can make a comment on a picture, right? And then someone else could make another comment on the picture, or they could make a comment on your comment.
Mm-hmm.
So those are like two different things on the same page, right? 2 different post methods on the same page.
Yeah.
So I guess it's just they would be identified separately. Like one would be like comment and one would be like response or something, and then
That's possible, or it could be the same route, just like different data being sent across, right? So like comments could just have you could have a thread, and then they could have a parent ID of your comment.
Oh.
So you're just like setting the parent ID of your comment to be the other comment, whereas the comment for like which doesn't have a parent doesn't have a parent ID.
Okay. Yeah. I was just like
so
trying to think about
right. That depends on the internal like how they architected the system. And yeah, but like there's no reason from having separate routes, but then they could also live in the same file. You can have 2 post methods in the same file. There's nothing wrong with that.
That's just my question.
But I think the design pattern of having different files for each route, each kind of resource you're modifying, and then having an index file, which is combining all of those different files, and then just referencing that index file in your server.js is in my opinion, pretty good. All right, we're done.
Jeff,
Yeah. Cool. Thank you all.
yeah, thank you.